Hello everyone, we are going to solve for the value of s from this Olympiad math problem, and the given equation is an exponential equation. To solve for the value of s from this equation, the first thing we need to do, if we consider this middle term 2 to the power of x, we can write this 8 in form of this, so that 8 can be raised to base of 2, and what can we raise to 2 to give us 8? So when we say 2 raised to the power of 3 is going to give us 8, then all raised to the power of x, then plus 2 raised to the power of x is equal to 130. So the next thing we are going to do, we call power property of indices 3, 2 raised to the power of 3 and all raised to the power of x. So we are free to multiply the two power together. And since multiplication is commutative, then we can switch the power so that the whole of this can also be written as 2 raised to the power of x, then all raised to the power of 3. So we just switch the power. So plus 2 raised to the power of x is equal to 130. So the next thing we're going to do, as you can see, we have 2 to the power of x, and also we have 2 to the power of x here. 2 to the power of x is common. So we can let any variable to be 2 to the power of x. Then later we substitute it back. So we can say let m to be equal to 2 to the power of x. So what this thing means is, anywhere we see 2 to the power of x in this equation, we are going to replace m. So we are going to have m to the power of 3, then plus, in place of 2 to the power of x here will be m, and this 130 is constant. When we take in to the left hand side, become negative 130. So everything will be equal to 0. So now we have cubic equation. So first thing we need to do is to solve for the value of m, then we replace it back before we get the value of x. So we're going to keep this m equal to 2 to the power of x aside first. So now let's solve for the value of m from this cubic equation. To solve for the value of s from this cubic equation, we are going to do manipulation in this middle term, because we are going to use factorization method. And to use factorization method, we must have 4 terms. To have 4 terms in this equation, we work on this middle term. Do you know that this m here can also be written as 130? One of the factors of 130 is 26. So when we write 26m, what can we take from this 26m to give us m? So when we take away, this 26 is positive. So when we take away minus 25m, you are going to see that minus 25 plus 26m is going to give us m. So the whole of m can be replaced as negative 25m plus 26m. So therefore, we are going to have m to the power of 3. In place of this m, we are going to replace negative 25m, then plus 26m, then negative 130. Everything will be equal to 0. Now we have 4 terms, so we can use factorization by grouping. So what do? We group the first 2 terms, and also we group the last 2 terms. So now if you look at here, m to power 3 minus 25m, what is common here? So m is common. So we're going to factor out the one that have least power, which is this m to power 1. So we factor out m, and we're going to open bracket. M to power 3 divided by m, it will just remain m to power 2. Then negative 25m divided by m, it will remain negative 25. So now 26 and 130 is constant because the variable is not common. So 26 can go into 130. So we're going to factor out 26. So we factor out positive 26, then we open bracket. 26m divided by 26. So m is going to cancel. Sorry, 26 is going to cancel 26. We are left with just m. The negative 130 divided by 26 is going to be what? Negative 5. So everything now will be equal to 0. So the next thing we're going to do, we have m now. Then we open a bracket, m to power 2 minus this 25 can also be written as 5 raised to the power of 2, so that we can have difference of 2 square. 5 to power 2 is the same as 25, then plus 26 into the bracket of m minus 5. Everything will be equal to 0. So the next thing we are going to do is to recall what we call difference of 2 square. So when we have a squared minus b squared, this can be factorized as a plus b, then multiplied by a minus b. So this is what we are going to work with in this bracket, only this bracket, so that we have m into the bracket of m squared minus 5 is in form of this. To be in form of this is going to be what? M plus 5, then multiplied by m minus 5. So we close the bracket, plus 26 into m minus 5, everything will be equal to 0. Remember, these are together and these are together. Now we check these two expression. What is common? We have m to power 5, m minus 5 here, and also there's m minus 5. So therefore, m minus 5 is common. So we're going to factor out m minus 5. Then we open a big bracket. So here, this m minus 5 is going to cancel this m minus 5. So we are just left with m into m plus 5. Then plus here, we factor out m minus 5. So this m minus 5 is going to cancel m minus 5. We are just going to left with just 26. So everything will be equal to 0. So the next thing we are going to do, remember, everything is in the bracket. The next thing we are going to do is to expand this bracket. So we're going to have m minus 5 outside the bracket. This is the one we factor out. Then we open this bracket. M multiplied by m is going to give us m to power 2. It's going to give us m to power 2. Then m multiplied by 5 is going to give us 5m. Then plus this 26. So everything will be equal to 0. So the next thing we're going to do is to recall that when two terms multiply itself to be 0, it's either the first term m minus 5 equal to 0, or the second term m squared plus 5m plus 26 equal to 0. So here we can say m now will be equal to 5, because when this negative 5 cross, it's going to be positive 5. So this is one of the solution. Now to get the remaining solution, we are going to get it from this quadratic equation. So here, to use factorization method here is going to be a little bit complex. So to make it simple, we are going to use general formula method of solving quadratic equation. And recall, to use general formula, the variable in that formula is a, b, and c. So a is the middle is a leading coefficient, which is coefficient of m to power 2, which is 1. Then b is the coefficient of the middle term, which is 5. Then c is the constant, which is this 26. So we are going to write the formula. So we are looking for m, which is going to be equal to minus b plus or minus square root of b square minus 4ac, then everything all over 2a. So this is the quadratic formula we are going to use. So therefore, to substitute all this our data into this formula, we are going to have m now will be equal to minus b is going to be minus 5 plus or minus square root of b square is going to be 5 square minus 4 into a, and a is 1, then multiply by 26, which is c, then everything all over 2 multiplied by a, and a is 1. So we're going to have m now will be equal to minus 5 plus or minus square root of 5 square is going to give us 25. Then minus 4 multiplied by 1 is 4. Then 4 multiplied by 26 is going to give us 104. So everything all over 2. So m now will be equal to minus 5 plus or minus square root of 25 minus 104 is going to give us minus 79 all over 2. So from here now, we don't even need to waste our time, because as you can see, inside the square root we have negative 79, which is going to give us a complex solution, right? So m now will now be equal to negative 5 plus square root of negative 79 over 2, or negative 5 negative square root of negative 79 over 2. So this is the two solution, and this solution, since the radical is negative, we are going to have what we call a complex solution. which is going to, our solution is going to include I, because when you take the square root of a negative number, you are going to definitely get I, and I is not a real number, it's an imaginary number. So therefore we can say m is not an element of a real number. So therefore we are going to ignore all the any solution we get from this quadratic equation because of this imaginary number, which is complex solution. It's not a real number. So therefore we're going to work with only this first solution, m is equal to 5. So to do that, recall that we let m to be equal to 2 raised to the power of x. From here, as you can see, we see m is equal to 2 raised to the power of x. So this is the right time to replace it back. So anywhere we see m, we are going to replace this as 2 to the power of x, because the initially we are asked to solve for the value of x, not m. We just let 2 to the power of x to be m for convenience. So now we're going to replace it back. So in place of m now, we are going to have 2 to the power of x, which is equal to 5. Now to solve for the value of s from here, we are going to take the log of both sides to the base 10, because as you can see, there is no way we can make the base to be the same. So we take log of 2 to the power of x, which is equal to log of 5 to the base of 10. And recall one of the property of logarithm, this power here is going to go back to multiply the log. We are going to have x log 2, which is equal to log of 5. Then we divide both sides by the coefficient of x, which is log of 2, and also do the same thing to the right hand side, which is log of 2. This log 2 is going to cancel this log 2. We are left with only x, which is equal to log 5 divided by log 2. We are going to recall what we call changing of base property, log 5 over log 2. So we recall that when we have log of A over log of B, this is going to be the same as log of A to the base of B. So this is changing of base property. So therefore, x now will be equal to log of 5 over log of 2 in this form is going to be what? Log of 5 to the base of 2. So therefore, the value of s is going to be log of 5 to base of 2. And if you want to get the numerical solution, when we press calculator, log 5 to the base of 2 is going to give us approximately 2.32. Therefore, this 2.32 or log 5 to the base of 2 is the value of x that satisfies this exponential equation. Thank you for watching, and please follow us for more videos like this. Thanks.